Hello, fantastic 7th grade Vikings. I'm going to show you in this video one way that you can create your Law of Conservation of Mass project.
So here are some examples of things that you might already have that you could use to model to stand in for atoms in your project. So I just looked around my house. I have a craft drawer. In the craft drawer, I found some beads. I thought I could cut these apart and maybe use individual beads to represent an atom. I don't have a lot of bottle caps, but this was another idea I had. I could use bottle caps to represent atoms. But remember, if I'm going to be, representing one element, all the bottle caps have to be the same for that element. So if I had lots of black bottle caps, that would work. I happen to have a bunch of stickers. I have these heart-shaped stickers, so there's a bunch of the same kinds in here. I do have some stars as well. I could use stickers. I've done a lot of sewing, so I have a whole lot of little safety pins. I thought I could just glue some safety pins on, and a safety pin, like one safety pin equals one oxygen atom or something like that. And then I also happen to have just one sheet of nothing but googly eyes. So I thought that might be fun too. Maybe I'll use googly eyes, where one googly eye equals one iron atom, or something like that. Because of what I'm doing, I happen to also own a glue stick, so I'm using that. If you don't have anything fancy like that, know that there will be a day in class that you can use to do some of your building. You can do all your building at home. You can do all your building and assembling at school. And if you want to do it at school, I will have a glue stick that you can use. And what I'm going to use to put it on, I want something a little firmer than paper. So I've got some cardboard boxes. I've got like a medium piece, and I've got a smaller, oh, come on over here. I've got a smaller, sort of a narrow, it's long, but it's narrow, and then I've got a big piece that takes up, more than I can show. These are all possible things that I could use to glue on my chemical formula, my model. So here's what I ended up deciding to do. I decided to use red heart stickers for my iron atoms. So I picked out only the red ones, right? So they're all the same. Every iron atom is going to look exactly the same. And then I cut off some of these beads from this little party necklace. So I have the green spheres are going to be my oxygen atoms. So one of the things you're going to need on your project is you're going to need to write the formula. Well, mine is iron plus oxygen yields iron oxide. And I know, we balanced this equation in class, so I already know that 4 iron atoms plus 3 oxygen atoms yield 2 iron oxides, Fe2O3. So I have that written down, and in a moment I'm going to make a little cut, and I'll show you how it looks in a moment. I'm going to have, just like we used in class, we used the dominoes to show different atoms. I'm going to be using these for the iron, these for the oxygen, and then I'm going to make a key down in the corner so that anyone looking at this knows exactly which of these stands for iron and exactly which of these stands for oxygen. So I'll show you in a minute what I ended up with. And well, here is my final product. So before you saw how I had the formula written up here for the chemical reaction, 4 iron atoms plus 3 O2s, 3 oxygen molecules, yield 2 Fe2O3s. Fe2O3, I've done some research, so I know that's iron oxide. So I've got that. And here you can see my 1, 2, 3, 4 iron atoms. Notice it's not Fe4, it's 4 Fe's. So they're separated. They are not touching each other. And then plus 3 O2s. I don't have them all together. I don't have 6 separate dots because I'm showing that there are 3 O2 molecules. I show a molecule when things are so close that they're touching. So there's 1, 2, 3 O2s. And that yields 2 iron oxides. Now again, I've done some research, and I know that the shape of an Fe2O3 molecule kind of looks like this. All right? So there's 3 oxygens and 2 irons, and it's an oxygen, iron, oxygen, iron, oxygen. And I have 2 sets of those. They're not all clumped together. They're separated to show that I have two separate molecules. I also, down here, I have added a key or a legend. This is what's going to tell people what each shape represents. So my hearts are iron atoms, that's Fe, and the green dots, that's oxygen, or the green beads, that's oxygen, which is symbolized by O. Now this is pretty good. It has everything I'm asking for. I've shown that I understand the difference between 4 atoms versus 3 molecules. Molecules, they're touching, they're all joined together, versus atoms that are by themselves. I've shown that I know which are the reactants and which are the products because I have that written correctly. I have a key. There's nothing innovative about this. This is not an 8. This is not like the most perfect thing ever. If you go beyond, if you do maybe some more research about your atoms, if you do something, if you show me, if you set this up in a very creative way, if you're being innovative, there's your 8, but this would be maybe a 7. This would be a 7 because I have everything I need and it shows I understand the different concepts. The one thing that's missing is my name. I'm going to put it on right now. I'm going to grab a little marker and I'm going to write my name down here because I can't give you credit. It's unobservable if I don't know whose work it is. You can write your name on the front, you can write your name on the back, but make sure you do that. Next week in class, I'm going to show you a couple examples that aren't as good, and you're going to tell me what's wrong with them, and you're going to grade them by the rubric. But for right now, here's a pretty good example. It's got the basics, so I hope that this doesn't get you too concerned, and I hope you have fun researching your chemical reactions.